Hi, it's Mrs. Pope, and today we're going to talk about complex numbers. This is part one of a two-part video. Today's goal is to solve equations with imaginary solutions. So we're going to introduce imaginary numbers today. Not real, they're imaginary, so we have to imagine them. The vocab, the imaginary unit is denoted by I for imaginary. And I is the square root of -1. The reason it's imaginary is because you can't take the square root and get a real number of a negative number. That would be like trying to take the square root of -25. Well, that couldn't be positive 5 because 5 times 5 will give you positive 5. Couldn't be -5 because -5 times -5 will give you positive 25. So the square root of a negative number is an imaginary unit because it's not anything that's real. So I squared is equal to I times I. And from our rules of multiplying radicals, we know that the radicals would go away and we'd be left with -1. So the two things that are very important to remember, I is the square root of -1, but I squared is actually just -1, which is a real number, so we can use that. Pure imaginary numbers are square roots of negative numbers. So -6, the square root of -6, the way we would say that would be, that should have a radical. Radical 6i. The square root of -4, excuse me, that should be 2i, because the square root of 4 is 2, and I represents the -1 that's in there. And radical square root of -3 is just I to pull out the -1. Radical 3. Can't break down radical 3 into anything smaller, so it just stays as radical 3. Alright, complex numbers are numbers with real and imaginary parts. So here we have 2 plus 3i, or 6 minus 7i. Here's the real part, it doesn't have an I. Here's the imaginary, real, imaginary. In general, for complex numbers, it's a plus bi, where a and b are real numbers, and I is just the imaginary unit. Alright, let's look at a few examples. Square roots of negative numbers. So as we mentioned, you can't take the square root of -25 and get a real number. So the square root of 25, that breaks down to square root of, let's say, 25 times -1. That's really what's happening there. Well, that means it's the square root of 25 times the square root of -1. Square root of 25, of course, is just 5. Square root of -1 is I. So your answer here would just be 5i. Now if we had to break down -27, we could break this down into first square root of 27 times -1, which is fine, but we can actually break this down into, it has a perfect square. So we could turn this into 9 times 3 times -1. Why did I do that? Because 27 has a factor that's a perfect square. So this is square root of 9 times square root of 3 times square root of -1. So I have them all broken down. Square root of 9, of course, is just 3. Can't do anything with radical 3. And then this is just going to be I. But just the way you will normally see it written, usually the I comes before the radical. So this is actually how you would see it written. And what about -216? Well, we could break that down into, of course, 216 and -1. Then we could break down 216 into 36 times 6 times -1. And the reason we did that is because square root of 36 times square root of 6 times square root of -1, this is a perfect square. So I would have 6, I'm going to go ahead and pull my I over now, radical 6. So that's how we break them down and take square roots of negative numbers. Now let's look at product of pure imaginary numbers. So these are two numbers that are imaginary and we want to multiply them. Well, the way we multiply them, we kind of treat I a little bit like it's a variable, but remember I squared is equal to -1. So we multiply the -5 and the 3 and we would get -15. And then we'd have I squared. Well, you can't leave it like this. It's not simplified because I squared is -1. So this really means -15 times -1, which of course is just 15. All right, let's look here. Square root of negative 6 times square root of negative 15. I want to multiply these and simplify them. This really means I radical 6 times I radical 15, which would be I squared, remember the I times the I, times, I can't break those down by themselves, so I'm going to multiply them together and see if that would help me. 6 times 15 is 90. It does, because now I can see that 90 has a factor that's a perfect square, which is 9. So this could be I squared times square root of 9 times 10. Of course, square root of 9 would be 3. So we have I squared. I'm going to pull the 3 out. Radical 10. I squared is negative 1. Negative 1 times 3 would be negative 3. And we still have our radical 10. This will be our final answer. Simplified. All right, let's look at one more example. Well, a little more. We have 2 equations with pure imaginary solutions. So if we were to solve this one here for x, I'm going to get x by itself. Well, at first I would try to subtract 64 to isolate x. So if I subtract 64 from both sides, I would have x squared is equal to negative 64. And if I take the square root of both sides, I have x is equal to plus or minus, remember that from when we solve square roots, plus or minus 8i. Don't forget the I, square root of 64 is 8. Simple as that. So here, I would subtract 100. 4x squared is equal to negative 100. Divide by 4, divide by 4. X squared is equal to negative 25. Take the square root. X is going to be equal to plus or minus 5. And that, 5i. And that will be our final answer. Remember to keep your plus or minus when you're taking the square root, because if I take the square root, I'm not sure if it's going to be plus or minus. I could have negative 5 here and square it and get 25, or I could have 5 here, square it and get 25. So you need to make sure you write plus or minus whenever you're taking the square root of both sides and solving for an unknown squared value. Thanks for watching, and remember, you are responsible for your own learning.